Gautam.
Yeah. First, look at this paper. This is make nice. Online modeling and the prediction of well-bed geometry in robot. This is expert system application. This is this general element to the soft computing techniques. CSC people generally they publish in this one. Its impact factor is 8.5. I used the methodology that work is simple one. The equipment we have. Even this one we can do with the manual metal arc welding. With that one also we can do. But the methodology which we use that makes more. So that methodology also I am going to discuss. Again. Yeah. So, in this session, I am going to discuss two methodologies. Just like that, I am not projecting here. I don't want to waste your time. I came to give you some useful things. It will be helpful to you to carry out research work. Generally, the people who are working this kind of institution like my university and here, we have limited facilities. Without limited facilities, however, even with our BTech students or MTech students, some experimental work we did somewhere else. So we don't know how to convert that one into paper. So some new methodologies like artificial neural network and other modeling techniques, these can be implemented in all engineering applications. It is not limited to one particular field. I belong to manufacturing engineering. The example is relevant to the manufacturing. You can also use in your application. So I discuss only two methodologies, artificial neural network in simple way. I don't take much time how to publish a quality paper. What methodologies we have got that I am going to discuss. Okay, we have different types of modeling techniques. What do you mean by this modeling technique? It establishes a relationship. It establishes relationship between dependent and independent variables. Dependent variables are outputs. Independent, they are the input variables. So the output variables we also call as responses. Response means the outcome of that one. So these modeling techniques will develop a relationship between the inputs and outputs. Once the model was built or developed, we can predict them. How to find that model, how to build that model, that we are going to see now. So we have different types of modeling techniques. So mathematical modeling techniques, just like regression analysis, response surface methodology, mechanistic models here. You should have idea of the physics in that system. We must have idea of the physics, what is happening behind that one. That we should know. Then only it is fun. These are the finite element modeling techniques. There also, you need to have any idea of this physics behind that one. The software itself it will take care of that one. While you are preparing this kind of mechanistic models, you must understand what is the system, what behind that one, what is happening on the process going on. And data-driven modeling technique, these are very, very easy, simple for us. All we are doing that one. We need not to go for any idea of that is what happening inside that one. Simply we have the experimental results based on that one we prepare modeling techniques called as data-based modeling technique. Okay. Yeah, these are the different types of generally we see these things. Taguchi method, this is one modeling technique. This can also be used for the optimization also. This one also used for optimization. Regression analysis. All these methods, these approaches establish relationship between the dependent and independent variables. Taguchi method, not only establishing the relationship, it gives some equation. In terms of independent variables, it gives equations for the responses. Simply, if you substitute these independent variables there, we can predict the response. So that is Taguchi. Even response surface methodology also it gives the equation. It has many more advantages. Majority of the people in the world living with this response surface methodology. It has other features also. Like it will analyze the data. So analysis of variance is also available. Significance of each independent variable it will identify. Optimizes. So that one, and it gives the 3D figures also. Surface graph, surface plots also it will give. We can see the trend of response and the input variables are varying. So that information also will be given the response surface methodology. Regression analysis, you can do this one here. For these two, you need to have a software like Minitab. For this one, even Excel is enough. In the Excel file, you can generate these things. And the FEM-based simulation. So we have the in different fields we have different answers like that. We have the FEM-based simulation software are there. We can simulate the process and predict that one. But this process will not show any equation. It won't give. It doesn't give any equation. But these three methods will come. Now, if we see the mathematical mode, this was a mechanistic models. If you see, we have to develop the mathematical models. To develop that one, we must know the physics behind that one. The concepts we know. Those things we have to interpret to develop the mechanistic models. And the last one, if you see the artificial neural network. So here also, it will not give any equation. It will not give any equation. It is a data-based modeling technique. So 1, 2, 3, and 7. These things will give the equation based on the data which we give to that. Based on the data which we give. If our data is correct, the prediction is correct. If you did the experiment wrong way, the results will also be not proper. So that's why you should take care of doing the experimentation. Then only these things can be implemented. Whereas if you see this one, we cannot escape. Because you will not change anything. Only boundary conditions, other things only you can change. The results you cannot manipulate. So here we can manipulate. If the equation not come as per our requirement, you will change something until you get the required equation. And like that, we do the modifications. We can manipulate the modification. Majority of the people, so what we are doing the work, we know the trend. What outcome will come, we know. If you detect that required outcome, we go for the manipulation. That kind of thing is not possible here in FEM-based thing. Okay, however, this artificial neural network we are missing in the artificial intelligence. Artificial intelligence, people are talking about that one nowadays. Trend, that is a trend. That is an application used to predict something, used to predict responses, something like that. In that artificial intelligence, we have the machine learning. It is a subsystem of that one. It is a statistical tool, machine learning. In the machine learning, we use the artificial neural network and other deep learning networks, those things we are using. What they are statistical tools, they analyze the data and predict the responses. But it will not give any equation. Generally, as we are engineering people, we have to handle the mathematical models also. We should be able to develop mathematical models also. For that one, we have to study the complete everything that in that problem, all the things, all corners we have to analyze. Okay, whatever. So I am going to explain the artificial neural network easily how we can do, how we can carry out that one for our work. So these are the examples for the mechanistic models. So like that, once if you know all the physics behind that one, then only it is ourselves we have to develop this one. So this is the example of that one. So mechanistic models. So once if you know using that mechanistic models, see this roundness. Okay, is this not required here? Okay, I'm going. This is time-based one. We cannot make any changes here based on the parameters which we give to that one software. It will simulate the process and predicts the what is the cutting force required. Like that, these are the examples for that one. So finally, artificial neural network. Say this is like one example I will tell you at the childhood that nursery on slate we write A B like that number of times we asked the student to overwrite that one. He will write 2 days, 3 days, then he has some idea of that one because he was trying writing over that one. So exactly A means straight lines like a sleep that is slant lines and across that one sleeping line like that we have. So if you draw like that, if you ask him what is that mean, he will say the A. So like that he was trying. Same thing only is implemented here also. Okay. So neural net is a part of nervous system in any animal having large number of neurons. These neurons are interconnected and treated as nervous cells. The concept of AI is derived from biological neural network. Okay, these are the introduction of that one. Directly I go to this one. See this. This is you have the 3 inputs, you have only 2 layers. So here, this one is output layer, input layer I didn't show here. Here we have one input x1, x2, x3, x4. So how we get the output? See this x some value here we have 0.2 or 0.3 or 1, 2, 3 like the some value we have x1. x1 into w1. w1 weight of the connection. w1 is nothing but weight of this connection, like that you have the weight to the connection. Say but suppose this is 1, 2, 3, 4, these are 0.1, 0.2, 0.3 to the example. So output of this one, 1 into 0.1 plus, 2 into 0.2 plus, 3 into 0.3 plus, 4 into 0.4. We get some value. If it is not with the target value, if it is not with the target value, if it is not close with that one, so our target value is some value, for suppose 5. If the output of this one is 4.5, error is 0.5 by 5. So that is more than target error. If you give the 1% as target error, the error is more than 1%. Then what we have to do? Then these weights we have to adjust. The weights of this one. You cannot change the input. Inputs we cannot change. These weights we have to change by changing the conditions. Am I audible? Yes. By changing the weights of this one, the error between predicted output and target output you have to reduce. That is our aim. So if you do the neural network using the MATLAB or using the Python or any codes, in MATLAB directly data can be given. You can write the coding also. It takes a lot of time. It may take more time. It may take days also. We don't have that much of time. Moreover that, we have to change many parameters there. You may not aware of that one. Only people who are working in that one, they have idea of all the parts in that ANN. All the things will be, they will adjust until you get the error less than 1%. You don't have that much of knowledge on that neural network. We want to publish our paper. We want to do work using the ANN. Then what you have to do? So for that one, you have one solution. Artificial neural network, Easy NN Plus. There is one software, Easy NN Plus. Using that Easy NN Plus, all these adjustments, the software itself it will do. The software itself it will adjust the weights of that one, learning rate, momentum, everything it will done. It will run the program until the error comes less than 1%, whatever the target error you give. So that I am going to explain now. Before that one, what is the structure of the neural network? If you see, like that we have the neural network. This one is 51484 multi-layer perceptron. Like that we call. This one is input layer. These two, the hidden layer 1, hidden layer 2. This one is output. As I belong to manufacturing, I took the manufacturing example. Okay, in any application we can use this. So here, these are the inputs. So 5 inputs I have, and I took 2 two hidden layers. How we take these two hidden layers also I will tell. This one is these are the output variables. So four outputs here we have. This is one simple example. One structure I gave, input layer, hidden layer. Here in the hidden layer one, you have 14 neurons. These things we call as nodes or neurons. We call them as nodes or neurons. You have three inputs where you have the three neurons or nodes. Similarly, if you have the responses for four neurons, if you have the five, like that you have to type that one, that information. However, we have the data. So before seeing this one, we have the, see, this is the data we have. This is the experimental data. Without experimental data, we cannot do anything with ANN. You take any database modeling technique, you need to have some set of data. Using the data, that model we find. As I said before, overwriting on AB like that. So we need to have the data to implement the ANN, any other modeling technique. Database type, not list based. So like that we have the experimental data. See, these three are the inputs. These three are the inputs. These four are the outputs. So if you go to the this is the easy and interest software. So this is around 25 MB available in the net. You can download, you can practice it your own. So where once downloading this one, here the data from the Excel file can be imported by converting the as per requirement of the software. See this one. For suppose you have the 20 samples. The 20 samples we imported here. So you come here. First block, if you see, first block. So here, if you come here, you bring the cursor here. If you put enter, this bars will display. So where this value, you type this value here. Here, this row is used for training the model or not. For that one, you have to select data, the row for the training, row for the validating, row for the testing. The query means for testing. So here we have the exclude. If each one is one experiment. If the experiment is not done properly, the responses are beyond the range. Then the software tells that particular row is beyond the range. Then what we will do? That row we exclude. Then it will not be included in the training. So like that. Say, and one more thing is that if it is input, you have to select this one as input. If you select this one as input, it will come in the blue color. So responses are, you have to select as output, these things will display in the red color. So we gave the inputs and the outputs we defined. So up to here everyone can do. So there we entered using of the ANN. Very simple. So far we didn't anything. We have the experimental data that we put here, and we told the software that identifying the inputs and outputs. Just clicking this one. So inputs are output. Training or validating. For suppose if you have the 30 samples, in the 30 samples, 15% for the testing, 15% for validation, you have to separate. So among 30-15% means 5 samples for the testing, 5 samples for the that is validation, remaining 20 for the training of the network. Simple. So here you see this one V. So this is in the blue color. So if you come this row, randomly you can select. There is no rule. This one for validation, this one for testing. There is no rule like that. Randomly you select some rows for the, that is 15% of total rows for the validation and 15% for the validation. Simple. Very simple. Nothing we did here. Now you go to the next step. So after putting that one, here we have the action. In the action, you come to the check grid. This one is check grid. Just you click that one by one you come. If you have any confusion, one by one you step you come here. If you come to the action, first check grid, it checks all the values within the range R. If any row column beyond the range, it will tell us we can exclude or we can make any changes to that one. So like that it will guide us. Once as for that one, if you exclude or change that one, it says that now grid is ready to create the net. Then if you come to this one, create network, it will come like this. So here you have to select the hidden layer 1 and 2. Up to 3 it is fine. Maximum we go to the 1 or 2 hidden layers are added. Now select hidden layer 1. If you want to use 2 hidden layers, first we select the hidden layer 1. And the number of neurons in the hidden layer, you give some random number, 10. No problem. You give the maximum. 10 neurons we give. After that one, after if you put OK, then this will be displayed. Learning rate 0.6. If you want, you can change. Momentum is 0.8. Target error is 0.1. Now if you put OK, the network will be run. Nothing you do. Nothing you will change. Nothing modifications you do. If it is in MATLAB or using some Python or other code, you have to do lot of work. It takes 5 days, 3 days, like that. Here it is not like that. Simply places that one, define inputs and outputs. First we selected a hidden layer. In the hidden layer, 10 nodes. We know the experimental data. We did the experiment. We have inputs and corresponding outputs also we have. What is our aim? We want to develop a model. If you give some data of input, it has to predict the responses. For that one, this model is done. How the model is trained? Something you have to say that one. That is what using that training data, the model is trained. Okay, if the see this one, after that one, after 10,700 cycles, it stopped. When it is stopped, when it has stopped this one, when the average training error less than the target error, we gave the 1%. 1% 1 by 100 is 0.01. When the average training error less than this one, 0.003, we stop. That software itself stopped. If the once it stopped, but if we found the average error is more than 1, then what we have to do? Then we have to go back. Here, number of neurons in the hidden layer 1 we have to increase. Again, we do that. Even if you get the error more than that one, it is not getting, error is not getting less than 0.01. Then we have to do, we have to take another hidden layer. In that one, you put 10 or 12 nodes. No problem. We don't do anything physical. Just we are giving the numbers. Then you run that one. Until by trial and error, somewhere else it will come. Somewhere else it will come. By trial and error method, number of hidden layers, number of neurons in each hidden layer, we change until we get the error less than 0.01. 0.01. Here we got this one. Then the program is on. So in the starting itself, we gave 5 samples for the testing. Then it will predict. Wait. Those are the predictors. See how much simple it is. This one you can publish a paper in high quality journal, more than 5 impact factor. It is novelty. Artificial knowledge. Like that, you have to create the story. We have 10 morning session, I told you. You have 10% result only. This 10% result, 90% of transcript is to be built with novelty, highlighting your outcome. That should be, the presentation should be novel. What may not be novel? The methodology presentation should be novel. Whatever the work you have, those things will be published. How much simple it is ANN? It is very simple to you. 25 MB. That one. Easily you can download from the net. Available in net. For that one, manual is also available. You can do that one. In any application, you can implement the artificial bottleneck. Anyone please? After that, we will go to the next method.
What about the case of images?
We have to decide that one. Image processing. That will, before that one, you should go for the image processing. CNN is there. That is high level.
Can we do this?
No, that. You have to. CNN is there for the image processing. Now people are using CNN. We are also using the artificial L2 manufacturing. Now we are this. We have digital twin. We have digital twin. That is digital twin. That is SCADA. That is supervisory control and the data acquisition. SCADA. SCADA. There we are using the CNN plus numerical simulation. Then one of I wrote one project on that. This is on the review at IIT Indore and DRT. Last month we gave a presentation on that. So CNN we are looking for. I will put customer.
Civil engineering కూడా చేయాలి. Civil engineering.
ఎవరైతే నేను చెప్తాను ఫస్ట్ మీకు డాటా ఉంటే అసలు స్టేబుల్ ఇస్ ఎలా దిస్ ఈస్ డాటా మోడలింగ్ టెక్నిక్ నాట్ ఫిజిక్స్ బేస్డ్ means it needs the data because the name itself saying data based modeling technique. Without data we cannot know. In the simulation we can do that separately for each application. The simulation software will be downloaded. That is different story. Using this technique, I published more than 5 or 6 papers, all SEA. Around, in fact, more than 5, 4. Like. I don't want to mention about that. That's why whatever the things have more impact, those things will answer it.
Sir, what is the name of this software, sir? 25.
Easy NN plus. Easy NN. Name itself say easy. Easy NN plus. You can do your own. That's a customer. Down with the world of the doubtless and opposite.
The minimum amount of data.
That depends on the network. If the minimum data is 20 or 30 samples, you will 15 also can, not less than 15. If you use that one, well, selecting the number of delays there itself will edit. See, thing is that for database here, in the database modeling technique like this here, if the training data, it can be used for 15 also, no problem. Can be very less. 15 and above you can do. Accuracy of this one will be increased based on the number of training samples you use. If you use training a large number of training data, if you give, its prediction will be very high. That is the accuracy of in prediction. Exactly it predicts. Even in US and other countries, the prediction of the planes and other stuff, they use this kind of system. They use thousands of data samples they use to train that. That's why they are able to predict exactly, accurately they are predicting. So when you use, if you increase the number of data samples, then the accuracy will be more. Here I will come to the another point. Always the China will see the shortcuts that everybody we know. Even in the manufacturing also, China made products we know. Simply they make whatever the lunch it is. Always they go for shortcut. So here I am saying, not myself, the model saying that how much data, training data you give, my accuracy is that means like that it is same. China people they developed some model technique, nonsense of this large number of data. I need 5 to 6 data samples with poor information that is enough to me to predict. That's all. I will tell an example. Generally, manufacturing industry, 4-wheelers or 2-wheelers. Okay, based on the previous data, they estimate the demand for the next one. Say, for suppose 23 sales data from January to December, that ANN the data and predict the forecasted demand for the 2024. Say for suppose demand is forecasted per month 1000 units per month. Now we are in the month of March. So every month 1000 products expected demand or sales. In the January we have 500 sales due to some situations, fluctuations, corona, whatever. In February also the demand is sales are 600. March also like that. Every month we produce 1000 like that. How many products we have in the gardens? So 400 plus 500, 900. This month another 300, more than 1100 we have in the there. So how much investment on the material, production cost, all those things are missing. Because if you produce the material the bulk amount, inventory is nothing but keeping money in the stores, that's all. Inventory, we are keeping them. If the sales are not there, the products we kept in the stores. Means we are keeping the money. We are wasting the money. So if you are able to reduce the production of that one, we observe 2 months sales. In the March actual what we have to reduce the demand of that one. We have to reduce the production of that. For that one, the solution what I am going to tell now. This is invented by what I am going to present now. This is developed by the China people in 1988. This was developed. They used grade prediction model. GM 1,1 or 1,n like that. It needs 5 to 6 data samples. It built model predicts exactly for the next one. And just before I told you, in the ANN or any other deep learning techniques, we use the 2023 January to December data. Using the data only, we predicted the demand for the 2024 January to December. You cannot change the demand in the May, June like that. You cannot change. Once if you fix the data for the training, that cannot be modified. That cannot be modified. In this method, grade prediction model, in the grade prediction model, the training data can be modified. Image created by me is not okay. See this one. Data samples, 7 data samples we took. We predicted the demand for the 8th period. To predict the demand for the 9th one, first data sample was removed and recent data was added. So updation of training data, updation of the training data is possible here. In the ANN and other database modeling techniques, it is not possible. That's why this became popular. In India, also people are using this one. But still, research is going on that one. Some uncertainties in this modeling technique should be defined. So that thing is going on by increasing the number of parameters here. It is also very easy thing. Okay, I am going to presentation. Okay, all these things are not required. Yeah, see this one. This is the additive manufacturing. One of the recent trends we are following in the manufacturing. Where see this one, components are made by adding the metal. If you see this one, just like welding, conventional welding in the same way, but we did on the robot-based welding. Robots are used in the additive manufacturing also. In our university, we have the robot is there. Using that one, this layer or wall is made in 10 passes. So here, height of that one vary. Actually, expected. Expected height like that. Uniformly, the layer should be there. But it is not done. So how to control this one? If you see from here, if you start the welding, at center height is more, at ends height is less. How to do that? So first we have to identify what is the cause for that. So this method is a grade prediction model. It identifies what is the cause for that one also will be identified. See this one, generally people who are working in that one, that current is the one of the factors, major factors that affects the height of that one. See in the welding process we know, okay, all of you know about that process. So where we do the welding. If you give the current, current passes from electrode to this one. Between the electrode and the plate, you have the atmospheric air. These electrons will collide with the molecules in the atmospheric air. These molecules will become positive ions and electrons. Primary electrons and secondary electrons, they are accelerated towards the workpiece, striking with that one in the form of spark. So where the heat will be generated means, see here how force that arc has, called as arc force. Based on the current, arc force is varying. Based on the current, arc force is varying. If the arc force is more, what happens here? The weld pool, we call as weld pool, its size will be increased. When the size of weld pool increases, it takes much material. That is why height of this one we got less. Because while you are doing this one, what is happening? Current is varying. That we cannot do anything. For that one, we have to develop a control system connecting with this kind of modeling thing called as online monitoring of height and the control. Online modeling and monitoring. Okay, for that one we have to control the height because current is the one of the major factors. See this one. How we have to generate the data for that one. How we generated data for that one. All these things not required to you. Yeah. See this one. This is pass number 1. Like that we have the 10 passes time. After 5 seconds, 10 seconds, 15 seconds, like that we have. After each 5 seconds, I put minutes here, sorry, this one is seconds. After each 5 seconds, what is the current? We have to measure. That measuring devices are available. We are measuring that one. After completion of that one, however you have the current, that using the arc force formula immediately calculates the arc force. And these are the depth of weld bed, height of weld bed. These things will be measured after each pass. Like that we generated the data. Let us assume. Let us see here. While making the first pass, say for suppose 20 seconds it took. At each 5 seconds of 20 seconds for each pass. After each at 5 seconds of interval, we measure the current. So we have arc force formula. Using the current, only current is the variable in the estimation of arc force. We can estimate the arc force. Okay, with respect to arc force, after that one, see at 6 positions, height of this one we measure. Height of this one we measure. Okay. Now let us come to the that. See this. This is the first pass. First pass at 6 positions we measure the height of this one, width of this one also. If you come to the second pass, the height is cumulated or not? Will be cumulated. In the third pass also, height will be cumulated. All the things we take. Just 6, these 6 passes, data is enough for that one. Okay, for ANN also this data can be used. In this way, the data is generated. There are 10 passes. We are taking the information of first pass to predict the height and the depth of the material deposition in the remaining passes also. For that one, okay, we are taking the
this first pass data only, that is current, this is the time in seconds, current. What is this delta and the current difference between these two? How much variation we have in the current, that one also we can estimate. Easily in Excel also we can estimate this one. So these are the three input four. One is time, current, next one is variation in the current, and this one is arc force. This arc force can be estimated using the current. We can omit this one also, no problem. You can take 3, or if you take 4, it will be more accuracy in prediction. That's why. Okay, that's right. This modeling technique, if you see, I am coming back. Just 1 second. I don't take much time. Exactly, we can understand easily. It is not complex. We feel it is complex. It is not complex. We feel it is complex. See, gray model 1 comma m. This one stands very easy if you listen. In 10 to 15 minutes, I will close it. Easily you can understand. If you write a paper with this one in SCA journal more than 2 impact factor or 3, it will be accepted. I give you assurance. It's simple matter. Yeah, simple arithmetics. Simple, very simple arithmetics. You don't do anything. In Excel file, everything you can make. Excel, we have the easy formulas in the Excel file. Easily you can do it. Or you can go to the MATLAB also. Okay, see this one. 1 stands for first order. What is this first order? So now, if you whatever the experimental data here we have, that is first order. Sorry, 0th order. Whatever the experimental data we have, that is the 0th order. First order. What is the first order? If you see, for this one I will tell. For this one, first order I am creating 5. Next one is 10 plus 5, 15. 15 plus 15, 30. 30 plus 20, 50. 50 plus 25, cumulative 75. 75 plus 38, 105. That is the first order. Accumulating the data is first order, right? Over. If you know these 2 points, remaining is easy. I am not telling lies, right? Yeah, one more point there. Ivanni with sort of nothing, just to understand first. One is first order, and accumulating of data. N represents inputs and outputs. Here, in the ANN, simultaneously more than one response can be predicted. Here it is not possible. Individually you have to predict. But even though with less data, with poor information, it predicts well. N indicates if the N is 3. If the N is 3, one response, 2 are the input parameters. That's all. If N is 4, 1 output, 3 are inputs. That's all. If N is 5, 1 response, 4 are the inputs. That's all. Okay. Now, even just formulas. So after seeing this one, you can understand. Don't worry about that one. So now let us go to the directly to the problem. Then only it will be very simple to you. Yeah. See this one 5550 order. First order. How you get the first? All these things are. See this one is one input, input, input. This is input. This one is output. These two are the output. Height and depth of material deposition. These are output. All these things are zeros, are 0th order. Means experimental data we took, that's all. That whatever the data we have in the table, where we have in the vertical order, here I put them in the horizontal order by putting commas, that's all. In the table form vertical I put there, here in horizontal by putting commas I put here. This is the 0th order. Now let us go to the first order. First order, see this one 5, 10, like that we accumulated all the data. Problem, half of the problem is over here. So up to here we have the output variables or input variables. These are the output variables. For these output variables, only one point I will add, nothing more than that. What I will add here, for this one, we have to take the average. That one also is simple. The average of these two. Z series you have to find out. Z series for each response you have to find out. The average of these two. Say for suppose D double, so this one is depth. Depth for the second row is the average of these two. For the third one, average of second and third. For the next third and fourth average, fourth and fifth is the average. Like that, we are doing the average for the responses. This one also easy. Z series we call. Z series only we take for the responses. Now we have to create the, see this one, OGM, optimization model. This optimization 1, 4. 1 stands for first order, 4 stands for 1 response, 3 inputs. What inputs we take? Time, current, arc force we took here. This is not generated by B. These are ready-made available as per the procedure I took that matrix. That values are placed here. 10, 15, these values are taken from here. See this one, 10, 15 like this. 66.9. This one. Like that, that horizontal things I put in the column wise in the matrix. Z series we took here. Z series. Average of, see this one, average of this one. 1.825 is the average of these two. Next one, this is the 2.99. 2.99 is the average of this one. 2.33 plus 3.65 divided by 2. That value is this one. This one. So like that we have. This is the 3 inputs, first order. This is the Z series, average series of that one. In numbers, there is simply 1, 2, 3, 4, 5. How many rows are there? Just input. Last row 1, 1, 1. As per the procedure. So now, why if you see, this one is the response 0th order. Response is the 0th order. Nothing you do, whatever the formula is written, as per that one, you put all the things. 1.01. That we take from the 0th order of 0th order. These things were 1.01. That is from second onwards we have. See this one. Here we put 2, 2, 2 like that. And the first row we omitted. Why we omitted the first row? Here in the Z series we took the average of 1 and 2 like that we take. First row we omitted. That is why all the things are too sweet. And then right. So after putting that one, you need not to worry about that one. This, if you do this multiplication, you will get these parameters. Using these parameters, responses can be predicted. Simple. So you have the matrix, B matrix here we have. This is the B matrix, Y matrix. We generated easily. Up to here we don't have any problem. We generated. Now go to the next step. B transpose. Columns, rows will become column. If you select even in the Excel also select that one, you go to say copy paste, it will ask transpose. B transpose. Okay. Now B transpose into B. We multiply Excel formulas are there. 1 minute it will take. It won't take not more than 1 minute. 1 minute. If you operate Excel or otherwise you take the how to multiply the matrix in the YouTube. 1 minute of YouTube videos we have using that one. You multiply that one. After that one, this multiplication inverse you make that one. Then you multiply with BT and Y. Then you will get these parameters B1, B2, B3, A, H1, H2. This is B1, B2, B3, A, H1, H2. These parameters will come. Using these parameters, U1, U2, U3, U4, all the formulas we have. Why this U1, U2 we got? This is the final equation. Directly I came here to make you easily understand that one. This is the final equation to predict the depth of element. It is not written by me. Okay, these are available there. That formula you have to convert according to our application. What we converted in place of response, I wrote only GW2. That only I changed. Now you come. Nu1, Nu2, Nu3, Nu4. Here we found. B1, B2, B3. These values. Substitute there, you will predict. That's all I think. Over. Completed. I think in Excel we do this one. In Excel we can do this one. Okay, here one thing. Okay, in this way. So here selection of input parameters. Nothing to worry. So here in this model, PIAM, these three parameters as taken as input parameters here. Here I took 4 input parameters. Here 3 parameters changed. In place of height, delta I placed here. Similarly for the height and width. So okay, using for the height 3 models we developed. For depth also we developed 3 models. Accuracy of 3 models we have to identify. How do you find out the accuracy? Experimental value we have 72 data we generated there. We took the data of first only. Using that one, the model is developed. We estimated the responses based on the error between them. Which model among these four models for height, 4 models for depth, we use based on the error. Which one is the best one? We can identify. Now you see here for this model, the error for this one for the depth of this one we take. Okay, sorry, selected. This one, sorry. This one is T current arc force. So here, if you take these 3 as the independent variables, the error for the height and the depth we found less. That is why these 3 parameters are the significant parameters affecting the height and width of the wall where the metal additive manufacturing. Instead of this one, I highlighted this. So this is about the online modeling and monitoring of any system. Only thing is that one data you have to acquire online. You need online acquisition of at least one data. Here online acquisition of data is current. Current online means look that one. So for online modeling, for other if it is not online modeling, the existing data is there. No need of online data. The previously collected data is there. It is not online. If you want to develop any online control system, one data must be online. That we acquired online. Yeah, please. I don't take much time. That's why. In simple way, I explain it. Anyone, please? You are feeling it is complex. It is very simple. If you want, I leave these PPTs here. You can follow that. Any doubt you can call by mail also. It will be helpful to you. Simple data if you have, implement this one, published in very quality journal. At least Scopus, at least TSA, definitely paper because the paper in the morning session I told you, the work which you wrote in that manuscript, it should impress the reviewer that we did some hard work. He feels that okay, this person did some hard work. We can't encourage him. Like that kind of positive attitude will be developed by seeing that paper. He will give a chance to publish the paper. That for that motto, not only here in other colleges also, this kind of lectures I have been giving to encourage the people a paper, if you publish on paper, 10% of credit goes to your college, 90% credit will come to you only. You feel that management forcing us to publish the paper for the benefit of them is wrong. If you produce quality papers, you will be identified as a potential competent person in the university or college. So I think this presentation is good. So I didn't go much in that one. Only I concentrated on the methodology. What is the methodology? How simple it is? How it can be implemented. I didn't derivate. I didn't make any derivations here. Complex things I didn't say here. Simple arithmetics I told you with more impact. By seeing all these matrix, the matrix simply is generated. When the reviewer sees that, he doesn't know what the behind that one. Oh, this person did matrix multiplication like that.